Hi, in this video, I'll finish up the H2 Mathematics 2022 Paper 1. So let's begin. The question is now testing you on your understanding of arithmetic and geometric series. And this first say that the arithmetic series first term is A and has a common difference D. And the first, third, and 15th term of this series is now the first, second, third of another geometric series. So because it's the first, second, and third, we know that the ratio will equal. So the second term over the first must equal to the third term over the second. And the third term is inside this arithmetic series to be the 15th term. So it's A plus 14D. So divide by the third term, which is A plus 2D. And similarly for the other side. So you get this equation with A and D's. So the natural thing now will be to cross multiply them, and you expand out to get the following equation. You see now that the A squareds cancel, and the AD's can bring over to the other side, so it's 4D squared minus 10AD. But because we know D can't be 0, so this allows us to divide off the D, and D would then equals to 5 over 2A. So next, we see a geometric series who has the first term sine and a common ratio of minus cosine. So they want to take the sum to infinity, so it's sine theta minus sine theta cosine theta plus sine cosine squared. But it doesn't matter how you write this, as long as you use the formula for sum of infinity, which is A over 1 minus R. So A is sine theta minus 1 minus cosine, so it's 1 plus cosine. So now you see that this is tangent. So what you need to do is get rid of the 1 here. And the way to do that is to use the double angle formula to expand out the cosine to cosine squared minus 1. So the 1's cancel. And because here is theta over 2 now, you can just expand the sine theta to be this. And you actually get tangent theta over 2. So k is half. Next, you're doing the same thing, but now using the formula to 7th term only. So it's 1 minus. So this is the formula. So then you just sub in theta as pi over 3, and you should get this as a result. For the next question, we see that curve C has this following equation, and we know that curve C has no stationary points. So we are supposed to use differentiation to find the relationship between A and B. So again, we just write out curve C, then we know we have to use differentiation, so we differentiate it. And then we consider this equation equals to 0. Why? Because here you can, when it equals to 0, you will have a quadratic equation at the end, which is over here. But because we know that there's no stationary point, there cannot be any solutions to this equation, and so the discriminant must be less than 0. This is similar to an earlier question we have done before, and the idea is always to use the discriminant method to help pull out, so you don't need to care about the x's. So now with the discriminant, you get the following inequality as such. Hope this is clear. Leave any questions in the comments and I'll answer them. So now we know that B equals to minus 2A, which fulfills this, by the way. So you need to take note of that. And we are now required to sketch the curve. So sketching the curve, you have to find the asymptotes. So first one is when you write out the equation, a clear asymptote, of course, is x equals to 1, since over here is 1. And then we know that the oblique asymptote will be whatever terms are here not having any fraction. So it's ax minus 2a. We know that there will be no turning points, and what we are left with is to find the points of intersection. So you let y equals to 0 and find for x. And for x equals to 0, y equals to a. So you just need to draw it out correctly, and it should get you the answer. Yes. So this is how you should sketch the graph. And a way to check, of course, is to use your GC and actually submit values for B and A that fulfills this, and then you actually see they will look something like this. But then, of course, the intersection point you need to find yourself. And on the same axis, we have to first to find AX minus A. We know that the oblique occidental is AX minus 2A, so when you shift it upwards. And to solve this inequality, it is actually recognizing that A equals to 1, which will feel, then you just sub it into here, so you just see how it works. And we see that when A is 1, the other side is x minus 1, so it's actually where the points of the graph is less than this line. So it has to be here, and everything here. So so you just need to find the point of intersection now, and then x will be just less than that, minus 2, and it has to be greater than where this line is, which is 1. Moving on, the question just tests your understanding of vectors. And for vectors, what I really like to practice is just writing points in terms of these position vectors, because it makes everything very simple, and I'll show you why. So they just tell you that P has this coordinate, so you just put OP as this vector, Q as this coordinates, OQ as this vector, and then PQ must be always PO. So you just imagine you go from point P to point O to point Q, and then you just draw this resultant vector. So it's PO plus OQ. So you can see it's very easy to remember the formula, because it's just how the letters work. And then you just get this following, and then we know that the length is 393, so you use the length formula for here, and then you get a quadratic equation in terms of P. You solve for P, and because we know that the level of P is below Q and up or down is through the z-axis, we know it has to be more negative than Q. So it has to be P equals to minus 36. As for part B, now they tell you that these 3 points are in the plane, so you just draw it like that. So vectors, a very important thing is you must draw it out, so it helps you visualize the scenario better. So you got A, B, and C here. So you just let OA, OB, and OC represent the points in the bin. You want to find the plane equation, so you want to find like maybe these two cut out, then find the normal. So you find AB and you find AC, you find the normal, and you can actually take out the scalar, so you get 14 times 5, 1, 2. So with that, you know that the equation of plane, you just need to take you can take this normal that you found, but you can just take a simplified one that is in the same direction, and then just times x, y, z times some point times the normal. That's the formula. And we know this will expand out of 5x plus y plus 2z. And as for the right hand side, you just expand out using the dot product, which is just multiplying and adding, and then you get 2560. And this will be the equation, Cartesian equation. See, they want Cartesian equation of the plane. Hope that's clear. We'll be moving on. And now we are supposed to find the coordinate where the pipeline meets the rock. So to find this, you just need to draw the pipeline, and you have the plane, the rock. So it must fulfill this equation and the whatever is in the plane. So first you got the equation of the pipeline, and you know that this point satisfies that equation. Then you just sub it into the equation of the rock. So you multiply by this 512 to get 2560, and you equate them, and you get that lambda equals to 1. With that, now you sub back into the equation of the pipeline, and you should get the point of intersection. So I hope that is clear, and we'll move on again. And lastly, we're supposed to find the angle that the pipeline makes with the horizontal. So we just have a horizontal here, and we draw the pipeline again. So we know that the horizontal has a normal vector of alpha. So what we are imagining now is if we dot it and find the angle with cosine inverse, we will find this alpha. But what we really want is this theta, and we will just later need to take pi over 2 minus alpha. So we just use the formula to find angle, because how to find it's just PQ times the normal must equals to P, the length of PQ times the length of the normal times cosine theta, and cosine theta is the angle between them. But because you want acute angle, so you just modulus everything, so it's just mod cosine. So with that, you just do it out and you see that you get alpha equals to cosine inverse 7 over 1313. So theta must equal to pi over 2 minus alpha, which is this 3SF. And for the last question in the paper, they are testing you on whether you can do differential equations. And so for differential equation, what you need to take note is to read the question carefully and put in every information that the question gives you. So first, they tell you that the model assumes that the rate of change is proportional to the population. So it means dp dt, which is the rate of change, must equal to some constant times p. So the way to solve this now is you divide over and you get this, and then you integrate it with respect to t. So when it's like integrating with respect to t, it looks like this, and then these t's will like somewhat cancel out, and then you get dp. And so with that, you get 1 over k ln p equals to t plus c. You multiply the k throughout, and then you take e to the power or something to get rid of the ln, and you get p equals to e kt plus c, which then you can write it as ec times ekt, and this part is just a constant a, so you just put a. Then now you use the initial information given. So they tell you that initially the population is 50. So when t is 0, p is 50, meaning a is 50. Because you just sub 0 here, this part is 1, then you just get a. And when t is 10, p is 100. So you get the following, and you get that k equals to ln 2 over 10. Then you are able to write the equation as p equals to 50 e to the power of ln 2 over 10t. And for the second part, they give you another model, and again, you just need to solve it. So with this, you just divide p and 500 minus p over. Do the same thing, integrating with respect to t. You get this as the following result. You expand out the partial fractions here, and you should get the following here. In this case now, you must remember to add modulus to the here, since there's a modulus when you integrate 1 over something with ln modulus. Why I didn't write a modulus here is because population has to always to be positive. But for here now, the 500 minus p may not be positive, so you need to put the modulus sign. But it doesn't matter, because when you expand out and remove the modulus, this portion, which is the modulus part, you know that it will become reduced back to a constant. And with that, you are able to solve again for a and lambda. And when you solve it, you are able to get this as the equation. Now all you need to do is cross multiply and simplify out to get some equation in terms of p, in terms of t only. And for the last part, it just tell you to state whether and comment on how the refined model is actually a better one. And how does the population vary in the long run for the refined model? Well, you get this as your equation from the previous part. So what you want to do is cancel the e at the top first. So you cancel this out. So you divide out. So this part cancels. So this become 1. So this 9e reciprocal. So reciprocal is just the negative. So with that, as t goes to infinity, we know that the explanation goes this way. So this part goes to 0, and it will be 500 over 1. So p approaches 500. So in the long run, the population will approach 500. And this is a better model, as in the first model, as t goes to infinity, the population goes to infinity as well. But this is unlikely due to the limited resources in the environment that will keep the population at a max capacity at some point in time. And so this makes the second model a better model compared to the first, because it accounts for this limited resources or the carrying capacity of the environment. So I hope now you understand how to better approach the questions in the paper. If you have any questions, please really feel free to leave it down in the comment section and I'll answer them. Please like, share and subscribe, and I'll see you in the next paper. Bye.